Inside this ship is enough oil to fuel an entire city's energy system. Some of the largest ships on Earth were built for one purpose: moving enormous quantities of oil across the ocean.
To understand these ships, start with their size.
Below this enormous deck is a carefully divided system of cargo tanks.
These tanks aren't one giant empty space. They're separated into multiple compartments. That separation helps control the ship's weight, balance, and stability. And that becomes critical when the cargo weighs hundreds of thousands of tons. And this ship may travel thousands of miles before its cargo reaches land. But moving the oil is only the beginning. The real challenge is keeping all of that cargo under control. Before the ship can cross the ocean, millions of gallons must first be loaded safely aboard. The transfer begins through enormous pipes designed to move oil at controlled rates. Powerful pumps push the crude through the terminal and into separate cargo compartments. As the tanks fill, the ship's balance becomes just as important as the amount of oil being loaded. Every part of the operation must work together before this floating giant can leave the port.
Once loaded, the tanker becomes a carefully balanced floating structure.
Too much weight on one side could change how the entire ship behaves in the water. That's why tankers also use ballast systems to help control their weight and stability.
Out at sea, these systems become critical when the ocean stops being calm.
Because keeping this giant stable isn't just about protecting the ship, it's about protecting everything inside it. Inside these enormous tanks, crude oil sits inside a maze of reinforced steel compartments. But above the oil is something you can't see: a space where hydrocarbon vapors can accumulate. That's why engineers constantly monitor the condition of the cargo and the spaces around it. That's why engineers constantly monitor the condition of the cargo and the spaces around it. From the outside, it looks like one enormous ship. Inside, it's a carefully engineered system designed to carry an extraordinary...
Deep inside the ship, a massive engine provides the power needed to move this floating giant.
That power travels through a massive shaft toward the propeller at the stern. The engine converts the fuel's stored chemical energy into the mechanical power that turns the ship's propeller. That rotating propeller pushes an enormous mass of water backward, driving the entire ship forward. Now the giant is finally moving, and its journey across the ocean begins. Far from land, the ocean can change faster than the ship can turn around. In severe weather, every movement of a ship this large has to be carefully managed. On the bridge, navigation systems help the crew understand exactly where the ship is and what lies ahead. Weather information gives the crew something even more valuable: time to prepare. Against an ocean this vast, the ship may look small, but everything inside it must remain under control. After thousands of miles at sea, the tanker finally reaches the infrastructure built to receive its cargo. A ship this large doesn't simply pull into a port. Its final approach is carefully controlled.
Once alongside, powerful mooring systems hold the vessel securely against the movement of the sea.
Now the oil has reached land. But its journey isn't over. Once unloaded, the crude oil can enter enormous storage tanks before its next journey begins. From the tanks, powerful pumps push the crude into the next stage of the network. From there, the crude can travel hundreds of miles through pipelines toward refineries. From there, the crude can travel hundreds of miles through pipelines toward refineries. One ship has now become part of a much larger chain, connecting the ocean to the refinery, and the refinery to everything that comes next.
Inside the refinery, the crude oil begins a completely different journey.
One of the first major steps is heating the crude and separating its different components.
Inside the towering column, lighter hydrocarbons rise, while heavier components remain lower.
Those separated streams can eventually become gasoline, diesel, jet fuel, and many other petroleum products. And from this one enormous facility, refined energy can begin another journey toward millions of people and machines. After refining, the finished fuels are stored until they're ready for their next destination. From these terminals, fuel can be loaded onto tanker trucks and sent toward cities and businesses.
But trucks aren't the only way fuel moves. Some products travel long distances through dedicated pipelines.
Some of that refined fuel becomes aviation fuel, traveling through specialized systems to airports. From one refinery, fuel can branch into countless routes, eventually reaching vehicles, aircraft, businesses, and entire cities. Once the tanker leaves, its cargo continues moving through a network far beyond the coastline. Inside the refinery, that crude is transformed into products that can power transportation, industry, and everyday life. Eventually, part of that journey ends at something most people pass every day: a gas station. That fuel can eventually power cars, trucks, construction equipment, and aircraft, connecting the tanker to everyday life. From a tanker crossing the ocean to the fuel moving through our daily lives, the journey is far bigger than the ship itself.
Much of the energy network is hidden beneath the ground, operating almost completely out of sight. Across the country, thousands of miles of pipelines quietly connect production, storage, refineries, and fuel terminals. Behind the scenes, operators constantly monitor pressure, flow, equipment, and changing conditions across the network. From the ship to the refinery, and from the refinery to the road, every stage depends on the next.
From thousands of feet above, the tanker is only one small piece of a system built to move energy across an entire continent.
An energy network this large is designed to keep moving, but even a temporary interruption can change what happens downstream.
When incoming crude slows, terminals have to adjust the flow, storage, and movement of everything around them.
Storage tanks act as a buffer, buying the system time when supply and demand don't perfectly match.
If a disruption lasts long enough, the effects can eventually reach the transportation network that depends on the fuel.
One interruption may begin at a single point, but the network around it is what determines how far the impact can travel.
While most of the world sleeps, the energy network keeps moving. Behind the machines are people constantly watching the system, making adjustments before small problems become larger ones. And somewhere else, another tanker is already beginning the same journey. Cargo moves continuously through terminals, tanks, pipelines, and processing facilities.
Inside the refinery, the transformation continues around the clock.
From there, the finished fuel keeps moving, often through thousands of individual deliveries. Some of that energy eventually leaves the ground entirely, powering aircraft that cross continents and oceans.
At the end of the chain are ordinary journeys, commutes, deliveries, construction, travel, and everyday life. And this journey doesn't happen in isolation. It is part of a global energy system connecting oceans, industries, cities, and millions of people. Estimates. From a single tanker crossing the ocean to the fuel moving through our daily lives, every step is part of a chain that